Android, iOS, Windows, Linux, Mac OS. You frequently hear those names, and you've probably used them yourself, but what are they? Well, those are specialized software called operating systems. An operating system is mainly used to manage the link between all applications, precisely between software and the hardware world, such as processors and other components. Keeping in mind that a computer is made up of three main components. They are the memory, the central processing unit CPU, and the input-output devices. First, the memory, which I will represent here with a small cylinder. The memory is used for storing data and accessing it when needed. Another important element in computers is the processors, also known as the computer's brain, which perform calculations and execute tasks based on the data they retrieve from the memory. And finally, so that the computer can communicate with the outside world, it has input and output peripherals. An output device such as a printer that produces data output, and a screen that allows data display. Input devices such as the keyboard and the mouse with which we can insert data into the computer. Internet is also an input-output component. Computers can run several applications. Here we have 3 different applications running. Each application will execute a specific task that depends on the use you have for it. In fact, for applications to use the hardware, you can't give them direct access to the computer's components. Instead, you'll use an operating system to connect the two. In English, OS stands for the operating system, and it will serve as the link between the apps and the computer. As we can see, a computer has 3 main components: memory, processors, and output-input devices. We can imagine the memory as being a large table with several entries we call cells. Each cell has an address: 0, 1, 2, 3. We can insert 4 words into the memory cells. Those addresses correspond to where exactly they belong in the physical memory. What an application can do, for example. In this one, it wants to insert the word Toto into memory cell number 1. It will be written on the computer's physical memory. Once the word has been written, it should be able to access it. But let's imagine that a second application wants to insert the word ZUT, but also in the memory cell number 1, so it will write here and it will replace Toto with a ZUTted. There's a problem here because if the first application decides to go back to the memory to retrieve the last data it had stored into cell number 1, it will obtain ZUT instead of Toto. That's not right. The operating system will be able to prevent such problems thanks to virtual storage. The idea behind virtual storage is that the operating system will give each application the illusion that each has the whole memory available. By thinking it has the whole memory available again, it will want to insert those forwards with a 0, 1, 2, 3 addresses. Each up will do the same. Now when an application wants to write something in the memory, it won't write directly into the physical memory, so it won't do this. It will write in the virtual storage instead. For example, it had chosen to write Toto on the cell 1. What the operating system will do when it receives a write-in-memory command from an application, it will convert it. It's going to find a space to write the data in the real memory. For example, it can say I will write the 1 here on word 3 in the memory, so Toto, so it will be written into the physical memory here. And the operating system remembers that the 1 for this application belongs in fact to the memory cell 3 we retrieved Toto in cell. Now if the second application here also wants to write ZUT on the cell number 1, then the operating system will find a space in the physical memory where the word ZUT can be inserted. For example, it decides to write it on cell number 1 ZUT, it will indeed be inserted here, and the system will remember that cell 1 for this app corresponds to cell 1 in the real memory. So from now on, if the first app chooses to read the word in cell 1, the operating system will remember the data was stored in cell 3. But cell 3 we retrieved Toto. There are no more inconsistency problems between the several apps that could overwrite one another. That's the aim of virtual storage. So the operating system will act as a moderator between the different applications in order to share the processor, because a processor is actually a little dumb, it just performs calculations and does only one task at a time. So if 2 applications want to use a processor, they have to wait their turn. Just like at school, when a pupil wants to ask a question, he puts his hand up and waits for his turn. The operating system will do the same thing through scheduling. Scheduling will say that an application has done enough calculations on the processor for now, so I'm going to put an on break to allow other applications to use the processor. What can also happen is that maybe this application does a calculation and at a certain point it has to read the hard drive is much lower than the processor. So the app will have to wait for the data, so it's going to retrieve the data from the hard drive, and during that time it stays on pause, which frees the processor for another application. Once that is done and the data has been retrieved, it will be able to go back to the processor. So with that, we have the first two elements. The last element is considering the computers are always different. There are lots of different modes. A cell phone is a computer, a chip card is a computer, your personal laptop is a computer, a big Google server is still a computer. What we want is for applications to be able to write without having knowledge of how hardware is actually made up. That's why the operating system provides an abstraction layer through system calls or system calls. Every time an application needs to execute something on the computer, it won't execute directly on the memory or the hard drive. No, instead, it will ask the operating system to do it instead. So for example, if an open app wants to write a rectangle on a screen for a game, what happens is the app asks the operating system to draw me a rectangle on the screen. The first thing the operating system will do is check whether or not the application has the authorization to draw on the screen. If it does, then the OS verifies how to perform the drawing and will execute the drawing in the application instead. The same thing happens if you want to read from a microphone. There is a microphone app, for example this one. It will say, I want to record the sound here, which is being retrieved by the microphone. To do that, the application will tell the operating system, I'd like to listen to the sound with the microphone. So the operating system will be listening via the microphone, and as soon as a sound event occurs, the microphone will relay a signal to the computer, which will generate an interruption for the operating system, and it will realize I have a signal coming from the microphone, and indeed that application asked me to relay microphone signals, so the OS will relay the right signal to the right application. So we saw that the operating system has three main purposes. The first one is managing the memory with the virtual memory, so it will enable an even distribution between applications. Safe memory management, so that an application cannot use a memory belonging to another application. The second purpose of the operating system will be through scheduling. It will allow sharing the load of the various applications on the processors. The last purpose is to abstract the computer's technical details from the applications, so that we can manage an application without knowing exactly on which computer it will run. The question you could ask me now is, there are Linux, Windows, Mac OS, Android, do all these different names have same the basic concept? Actually yes, conceptually it is the same thing. What changes is the ecosystem delivered with each system. iOS is more network and developers oriented, it is more dedicated to final users' games, but also usage license. Some systems are locked so they cannot be modified, other systems are open, so they can be modified at will. So depending on what needs you have, you will choose one system over another, more or less dedicated to what you intend to do.